it's Dennis again. I am here with John Novak from Velocity Architects, and we're on site at a home that's being constructed here in Bothell, actually just up from downtown Bothell. You can see here, kind of modern design, but a whole bunch of system upgrades that you're not going to see in your typical home. Just really unique, what's typically referred to as green home construction. And John's going to go into more detail on what some of the systems are that make that more of a green home. So,
well,
what do you got, John?
Well, starting off, the house is super well insulated. We're covering the entire house with about 4 inches of wood thermal insulation on the outside. So imagine covering the entire house with a warm, cozy blanket. So that minimizes all thermal bridges through each one of those studs on a typical house. So fully insulates it. Next thing is we're taping all the plywood sheet. See, you can't see it right now, but underneath that black stuff, all the plywood that sheathes the entire house is taped. So it completely stop any air getting into any cracks or crevices through the plywood. The floor is going to be fully insulated with a membrane underneath the insulation to keep any air currents that get into the cavities out, right? Because convection currents, they reduce the thermal insulation of your typical bath fiberglass insulation, right?
Right. Okay.
So that's one reason why we tighten the house. The other reason is for moisture control. It reduces the chances of having mold or anything growing in places you don't want. So improve thermal performance and mold moisture. And then we are also going with a high performance triple pane windows from Europe. So they have a good, stout, very well insulated frame, and they're triple pane obviously. So they get a very good U value. So hopefully the house will have a mean radiant temperature so that every surface in the house will be more or less equal temperature. So that is going to make you feel much more comfortable. That makes you feel much more comfortable so you don't have this drafty corner, everybody stood next to a a single pane window, right? And you feel that heat just leaving your body, right?
The heat transfer,
Yeah, so we're just taking that to the next level.
Okay.
With that, the roof is also going to be insulated from above, so again, full blanket. What else we do? So when you have a tight house, you gotta breathe. They say it's breathe, but you gotta provide ventilation. So we have the Cadillac ventilation unit. It's called the HRV, heat recovery ventilator. It's going to take heat. It's going to take air from basically every room in the house and exhaust it out at a constant flow.
Okay.
And before it takes it out, it's going to take that heat that's in that air and it's going to transfer it to incoming air. So it's kind of using the free heat incoming air. So the incoming air is not the outdoor temperature. It's raised up to almost 90% of the outgoing.
Oh, interesting. Okay.
Yeah. So you don't have those drafty currents when you do have fresh air. So constantly bringing in fresh air, exhausting stale air, really keeping the house fresh. See what else? High performance. The house is going to be heated with hydronic radiant heater. Hydronic underfloor heating. Very cool and even temperature throughout. And we're using, to heat that water, we're using the state-of-the-art CO2 heat pump, which uses CO2 as a refrigerant instead of your standard
Freon or
it's not Freon, but 134
ammonia or whatever.
Which has a very high global warming potential, like 1200 there, right? Where CO2 has a global warming potential of 1.
Right.
And the other thing is it's very efficient. So the CO2 heat pump has a efficiency of about 5, 4 to 5, depending on the outdoor temperature. But so much more efficient than your standard heat pump water heater.
So how does this compare? So most people are familiar with, say, natural gas heat in conventional construction. How does this compare with that?
This is an all-electric house. Natural gas is very inefficient, or it's very bad for the environment, because you've got crevices, and so that methane just sticks in the air, and it's a huge global warming potential.
Right.
So we want to stay away from all natural gas. So we're still using that heater, using that hot water. We're still making hot water. We're just using electricity to do it instead of using gas.
Right.
And then the homeowner, like everyone, likes using gas for cooking. Well, we're going to be using what's called an induction cooktop, which I think actually works better than a gas. And I've heard stories. I love my induction.
Well, I know a lot of professional cooks are actually going to those. They prefer
Exactly.
them in the kitchen.
You get more control actually
Right.
from than gas, because most gas ranges, like something like 90% of the heat that you're pumping into that actually just goes out over your pan and out, right?
Okay. Yep.
So, so you're just throwing heat out the up through the chimney, and then every time you use any sort of combustion appliance, you are putting toxic chemicals into the air. So even if the range hood is not fully sucking that air out, missing some particles, you're getting burnt toxic chemicals in your house every time you cook, right?
All those hydrocarbons and all.
Exactly, hydrocarbons. And so we are still having, it's a high performance house, so we are still using an exhausted range hood fan. But it's just
Mike actually mentioned something about that. He said this is like super. It's really interesting. I want to hear more about this, because he was talking about how you have to actually heat the air coming in and kind of manage the whole system there.
Yeah, the issue is to get really good proper airflow for a range hood, right? You really want that fresh air to come in from below and then waft up and then come out and go up, right? So it captures all that air that's surrounding the cooktop. But to do that, then you're putting the cold air, if it makeup air, comes through it's cold. It's temperature of the air outdoors.
Kind of defeats the purpose of having a heating system.
It defeats the purpose. You got cold air blowing on your feet or whatever.
Right.
So we want to put a powered makeup air somewhere else in the house that tempers the air before it comes in the house, and it's still pretty good as far as my understanding anyway.
Right.
Is as far as the exhaust range hood.
Yeah.
And you got to remember, we also are constantly having the HRV constantly bringing in fresh air all the time. So between those two things, I'm very confident that it's going to have very good quality air.
Yeah.
One thing we are doing is providing powered makeup air versus passive. We're going back and forth on whether that's needed or not, but in this case, we're doing that.
Right. Well, and one of the challenges that you're trying to address with that is the fact that you do have an extremely tight envelope on this house.
Yes. So if you're pulling air out, you're going to pull air through any other crevices. And so we want to provide that makeup air in a central location, so you're not, even though it's an extremely tight house, you still have a chance of one or two gaps, right? It's not completely 100% like tight. So, and where those little gaps are, you could have a little bit of moisture buildup. So we still want to keep the house nice and balanced, right? That's what I forgot to mention about the HRV is it's not just exhausting air at the same time as pulling air out. It's keeping the house pressure balanced, right? So your typical house has exhaust fans in your bathrooms, right?
Right.
So the house is constantly being negatively pressurized. So it's pulling air from every little nook and cranny in the house. So like say it's a house on a crawl space with unconditioned crawl space. You got rats living down there, so you're
pulling that air.
You're pulling that air through your crawl space up into your joist bay and then into your house, right?
Right.
So
So this is going to be a balanced air pressure as opposed to a positive or a negative.
Exactly. Yes.
Okay.
So this is another benefit.
Interesting. Okay.
Yeah. Let's see what else you're talking about. I'm sure there's more.
So hot water. Hot water heat?
The hot water system is a dual that I talked about earlier. The Sandin, Sandco system is a CO2 system, but it's doing dual purpose. So we're going to have it's going to have a heat exchanger to provide heat to the floor, and then homeowners will still have normal domestic hot water. And what's so nice about it is you got no heating elements or anything in there to corrode or pollute the water that's coming into the house. It's a dead stainless steel tank, just completely empty, right? So the water should be also nice and.
So other than the environmental benefits, what's the rationale for building in this particular way? What's the reason for that?
It's absolutely comfort. It's absolutely comfort. It's I just think people like radiant floor heating systems, right?
Right.
And the reason why they like that even temperature, and that's why most people are used to it. But in this house, you almost don't need the radiant floor heating system because it's so well insulated. The whole house is going to have that temperature. And again, that goes back to comfort. So you just have this, you don't have this drafty effects that you have in your normal house. So you're healthier because you don't have draft effects. I personally live in a better than code built house, more insulated. I feel like I get sick less now because it's not drafty.
Right.
and you get much more fresh air. So
Okay.
so that's the health benefits are really
Right.
I guess the also thing is with these turtle pane windows and this Gutex insulation that we're at in here, this house should be very bomber quiet, very quiet
Ah, okay.
from outdoor noise.
Right.
Because the Gutex is actually used in acoustical installations.
So how about say monthly operating costs? What are you anticipating to see? on
Oh,
that?
that's a hard one. I really don't want to speculate on that. I would assume 50 to 60% at least.
Reduced from
a
typical.
typical house, but every house
Yeah.
is. You really have to define your operating costs and how you use it. You know,
Right.
when you have such low heating bills, actually hot water then becomes the next priority. When you have a house
Right.
like this, right? And then on top of that, it's the appliances that someone will use, like your TV. If you're using a plasma TV, well then, you know,
You're offsetting
your
things.
load, your plug loads become a much big factor of your overall percentage of your use.
Gotcha. Okay. What other philosophies do you kind of plug into a project like this? What are you thinking when you're kind of coming up with the overall package?
Well, the design of the building has to matter significantly. You know, I don't believe that it's the quality of the space, it's the quality of the building that makes it last a lifetime. So there's an interesting feel, an interesting quality of spaciousness, and it's going to be around here for a while, long term. You know, 100 years from now or so, right?
Right.
It's not going to be torn down because it's who wants to care for, right? You know, these old houses, they have character, and that's why they're still around. It's because
Right.
we love the character, the wood creaking to the floor. So I always try to think in terms of not just making an energy efficient box, like what's most energy efficient. It's about finding that balance between energy efficiency, comfort, and aesthetics,
Right.
and a quality product, right?
Yep.
And that's the hardest part. You know,
The way the light comes through, the way the space,
Exactly.
the way it sounds, kind of all of those elements.
exactly. It's
Yeah.
just as important as the energy efficiency
Yeah,
here, right? It's not.
you bet. I mean, it's ultimately living space.
It's living space, and so.
Well, we're going to go inside now. We're going to go take kind of a look around. Obviously, we are in construction, and so there's a lot going on. There's probably going to be a lot of noise. It may be a little challenging to hear some of the things we're going to be talking about, but we'll fill that in as we can. But I'll just kind of go give you a scan through the interior so you can kind of see what that looks like, and then we're going to do some updates on this as the project moves forward.
Nice. Yeah, I'd love to do that. Love to share this, spread the word about green building as far as its comfortness and it's the right way to build for long term.
You bet.
And the more people, you know, maybe not everybody has to build a house like this, but they can apply some of the principles that they're learning here. Like one of the houses, actually we met these clients. The house that we built, another high performance energy house. The contractor's now using some of those principles in other code built houses that he's using, right? So I'm hoping to pass that on.
Well, I think that's the really interesting part about this is that it's like anything else where the technology advances. Ultimately, it begins to just kind of spread throughout and become part of the psyche of the industry.
And at that point, it doesn't really become that much more complicated. It's just now the people are used to it. They know how to do it.
The systems and the methods get standardized.
You can easily exactly. So
yep.
You know, I think the cost of doing performance house like this has come down because the materials are much more readily available. People know what they're doing, rather than 10 years ago.
You bet. Well, let's go take a look around.
Yeah,